All right, hello everyone, and thank you so much for joining us for today's Applied Data Science and ScienceOps demo webinar. My name is Elise. I lead the growth team here at Yhat, and I'm joined today by our co-founders Greg Lamp and Austin Ogilvie. So before we dive into the webinar, I just wanted to go over a few brief housekeeping items. First of all, we are recording the presentation and we'll be circulating the video and the slides in the next couple of days, so no furious note-taking is necessary. And second, I will be moderating the chat, so any questions that you have in the bottom left, there's a little Q&A form and you can submit those to us. And we'll save a few minutes toward the end. And just as a heads up, this should be about a 25 to 30-minute webinar, including questions. All right, with that, I'm going to hand it over to Austin. And thanks again.
Thanks, Elise. Hey guys, really excited to introduce you to the company for those of you who don't know us and show you a little bit about what we're working on in terms of data science and decision-making solutions at Yhat. So a little bit about us, just for context. We are a startup company in New York. We've been around for about 3 years, and we help data science teams go from prototype to production applications quickly, efficiently, and reliably. And I'll dive into a little bit about what I mean when we talk about production and decision making and some of these buzzwords as we get going into it. And then Greg will walk you through a platform demo of our flagship product, which is a decision-making system for data scientists. We are also active in the data science community. We have a number of open source projects and a blog. If you haven't checked out Rodeo, you haven't heard of Rodeo, it's an IDE for Python that we're really excited about. It's pretty new. We would love you to check it out and give us some feedback on that. So to set the context about what we're going to be talking about today, the sort of core focus of our company is in helping data science teams accomplish their goals in terms of commercial applications of the work that they do. So if you think about sort of what distinguishes academic research from commercial data science teams is the end goal being less about explanation and more about real-time operational impact in terms of improving the way a business makes decisions, the user experience for a consumer application, whether that's an iPhone app or an Android app, or internal employee-facing applications. And sort of examples are all around us of data being applied in really creative and elegant ways to create some of the stickiest and most personal application experiences, whether that's guiding users through paying their taxes without an accountant sitting right beside them in TurboTax, or the way Uber handles surge demand and pricing dynamically. All of these are sort of around us. And what we talk about, or what I mean by production applications, is it's always focused on applying real world applications. Instead of explaining to people, it's less about explanation and more about production. And the big hangup when the data science teams face, and the one that we initially set off to solve, was bound up with the schism that's created between a data science team on the one side and a team of application developers on another side. So from the moment a data science team has conceived a solution to a real problem, whether that's a churn model or a retention strategy or a credit scoring algorithm or a recommender system, a lot of data plumbing needs to get put into place in order to convert R scripts or Excel workbooks or PowerPoint presentations, which are sort of the byproducts that come out of doing data science work, into a sticky and engaging iPhone experience or web experience. And the schism is sort of twofold. One is organizational challenges that are oriented around the way a data science team thinks about problems, the way that they think about success in a given project, are very different from the framework through which application developers do their work. And so there's a need for closer collaboration between these two teams that can be very challenging to accomplish for many companies. At the same time, there's a host of technical challenges that these two teams need to overcome as well that we've observed consistently in working with our customers and in prior lives before we started the company a few years ago. And those are bound up with the statistical programming tools that data science teams are using are fundamentally incompatible with the most popular and most common application frameworks, development frameworks that developers are using to create apps that customers use. And so from a manager's perspective, certainly a non-technical person's perspective, it seems as though these two teams are both writing code and you should be able to work side by side harmoniously, and that couldn't be farther from the truth. The frameworks that data science teams are using are extremely well suited for certain types of tasks that would be very, very difficult to accomplish in their counterpart frameworks and languages that the app developers are using. And on the same token, application developers have a host of programmatic faculties that they have access to through their languages and tool choices that would be very, very difficult for a data scientist to accomplish. So there's a need to bridge the gap between the languages and tools that data scientists are using and those on the app side. And the field, data science, is relatively new buzzword, and so the results are still coming in, but so far there's a lot left for us to accomplish in terms of data science productivity in the real world for the majority of companies. In terms of the proportion of projects that actually make it into an operational, day-to-day impactful setting, it's relatively low. And in terms of what we specifically, the way that we've thought through this, sort of table stakes obstacles that you need to overcome are obviously associated with how do you take a decision-making model and simply make it available and accessible for use in another application is sort of step one. If you can't consume a recommender routine that's written in R, you can't make recommendations in your .NET or your Ruby on Rails application. But beyond that, there's a lot of downstream considerations that data teams that are sort of thought leaders in the space are thinking through that the majority of the enterprise is still catching up to. And those relate to understanding the value of a model and its effectiveness. Models tend to decay naturally as business conditions change. A third-party data vendor may change the API that you're consuming, and all of these sort of natural or organic changes that are to be expected in the real world need to be sussed out manually by data scientists and engineers on one-off ad hoc bases. So knowing when your model needs to be refreshed or tuned or honed is very, very manual at this point. Similarly, the exploratory nature of the field necessarily implies that in order to capitalize on a data science investment, you need to be able to make changes relatively quickly, and then those changes certainly cannot be as painstaking as the initial implementation. Otherwise, your team is highly limited in terms of its ability to run an experiment, learn something, and adapt. So when we set off to address some of these issues, we looked at high and low for a solution that was out there. There was nothing out there that could satisfy these three points of how do I deploy a model, how do I measure a model's impact or its business efficacy, and how do I adapt and make changes on the fly at the speed of business. And I'm going to turn it over to Greg, who's going to dive in and tell you a little bit about the way that we came up with to solve these issues, and he's going to walk you through a live demo of the platform.
All right, thanks, Austin. So, of course, the solution to this problem that we have come up with is our very own product called ScienceOps. So, ScienceOps allows data scientists to take the work that they've done, so that's analytical models, that's business rules, anything that they've produced and easily and quickly integrate that work into applications or into the workflow of application developers. So you can think of it as ScienceOps sits in the middle between the data scientist and the web developer or the software engineer, allowing data scientists to take their work and deploy it onto ScienceOps, and then subsequently allow application developers to integrate those deployments into their own work. So just really quickly, I'll touch on what that looks like before I dive into the demo. So ScienceOps is a clustered architecture. We have a master node and then what we call prediction servers that sit underneath that. The way that it works is a data scientist can do their work in R or Python. Once they have a predictive model or predictive routine that they want to expose to other individuals at their company, they will deploy that model onto ScienceOps, where it'll be stood up as a REST API endpoint. And then from there, that endpoint can be integrated into other applications. So whether those are could be internal consumers or internal employees or other teams that are using that model. It might be outside applications or third parties that are using and consuming that predictive model, or it could be a mobile or web app that's using the results of those models to power some sort of user experience or risk or decision-making process. So with that, I think the easiest way to show you guys how it all works is to just walk you through a really quick demo. So in the example today, I'm going to build a risk model using some credit and loan performance data. I'm going to take that model and deploy it onto ScienceOps, where I'll show you how easy it is to integrate that model into an example application. And then I'll showcase some of the monitoring and auditing features that ScienceOps has that allow you to manage that decision-making process over the course of its lifetime. So to start with the demo, I'll jump over to my Python development environment. In this case, I'm using Rodeo, which Austin mentioned it earlier. If you haven't checked it out yet, you definitely should. You can download it for free on our website or check it out on GitHub. It's open source. So for the demo and example today, I'm using a dataset that comes from Lending Club. So this dataset contains a few thousand rows that are each correspond with an applicant who applied for a loan on Lending Club. So you have a lot of sort of the basic financial data that comes with evaluating a risk decision. So things like credit score, bankruptcies, and then ultimately whether that individual paid back or did not pay back the loan. So what we're going to do is take that data set, load it into Python, and build a really simple logistic regression model that will allow us to determine which individuals are the least and most likely to pay back a loan. So to do that, again, I'm using Python, scientific Python, some of the standard libraries, pandas, numpy, scikit-learn. And it's really just sort of data science as usual for me, doing things like creating derived variables, cleaning up and aggregating certain columns or variables in my data set, picking out the right features to use, and then ultimately actually building the logistic regression model that's going to be calculating the risk for my new applicants. So once I have that model, that's sort of where we're left with this what next or deployment problem that ScienceOps really helps with. So to actually take my logistic regression and the set of rules that I have around it and deploy it as an API, it's really easy to do with ScienceOps. You just install our Python package and import it as you would any other library. And this library works, also has an analogous library for R as well. So if any of you use R, it works just about the same way. So import our package and then specify how you would like to execute a single prediction. So in this case, what that means is taking a new loan applicant, inspecting the data and the attributes about that individual, and then making a prediction using my logistic regression model about whether or not I want to make a loan to that individual. So once I've filled out that helper function, that execute function, defined what my model is going to do, actually deploying it is really simple. It's really just a matter of authenticating via our API and then deploying my model in one line of code here, giving it a name, executing that deployment. And what's going to happen here is that everything that my model needs in order to execute is going to be bundled up. So that includes my logistic regression model, that includes any data or helper functions that I've written, any third-party libraries. All of that is going to be bundled up and sent over to our ScienceOps server. So I'm going to jump over to ScienceOps here, give you guys a taste for what that looks like. Oh, that's the webinar. That's something else. There we go. So our ScienceOps server is, in this case, we're running it on our own internal AWS account, but we can install the software anywhere. So whether that's behind your own firewall, in your own AWS environment, or Rackspace, or whether that's in your own data center, ScienceOps can run wherever it is that you need it to. So I'll log in here and take a look and see that I already have my lending club online. So I'm going to dive in a little bit here and show you what that actually means. So what's happened is the model that I just showed you, that I just deployed from Rodeo, has been transferred over to ScienceOps. All of that data, that model, those Python packages have been unpackaged, and we've stood up an API endpoint that we can now call and send in new data points and receive back a prediction from the model that we just created. So this is sort of the nitty-gritty nuts and bolts of what the API is actually doing under the hood. Where that's relevant for our customers and the people that we're working with is that this model that's predicting risk in this case can be integrated into really any other application, backend process, really anything else that it needs to be. We actually have some code snippets baked into the products just to give you a sense of how easy it is to integrate a model into another application. You can actually just copy and paste this right into your app, and that's really all there is to it in terms of embedding a ScienceOps model into another application. So I actually have a demo app that will show you just how simple it is to integrate my lending club model into a web app. So what I've got here is a really simple web app that's written in JavaScript. What it allows me to do is have an individual will come in, fill out some basic information about a new loan applicant, and when we hit this score button, what happens is that behind the scenes, I'm actually calling that lending club model that's deployed onto ScienceOps, returning those results in real time back to my application here, and then we're rendering that as a chart just to give the user a little bit more context as to the results of the model that they're using. So again, that integration is really simple, just 1 or 2 lines of code, and the engineer only needs to get involved one time. So what's really cool about that is that as the data scientist, I can continue to come back into my Python script. I can make changes and edits to my model. So let's say I want to come up with an entirely new algorithm or new strategy for predicting risk. I can switch over to in this case, I'm using a random force classifier to predict risk. I can drop back down here and redeploy that model. And what's going to happen is, again, we're going to bundle up everything in this Python script. It's going to get the new version of the model that I just created. I'm going to jump back over into my over to ScienceOps. And what you can see here is the new version of my model is building. As that model is building, before it actually goes live and is being used as a production endpoint, we're going to run some unit tests against that model to make sure that it's performing and is accepting and returning back the correct data so that nothing on the integration side breaks. And then now that that model has passed the unit test, it's been deployed into our production environment, I'm going to jump back over to the demo app here. And what we're going to see is that I can rescore this individual, and the data that's coming back has actually changed since we're now using a new model that is better calibrated for this particular decision-making problem. So what was really cool about that, and what you didn't see, is that there was no, we didn't have to reintegrate this model. We didn't have to get any engineering or software developers involved in changing the code of the application. The data scientist could really own and handle all of the model deployment aspects of this application on their own, without having to get IT or engineering involved. So that sort of does it for the kind of the nuts and bolts API aspect of ScienceOps. The second piece of ScienceOps that is really helpful is a little bit more on the auditing and decision management, decision tracking side of things. So what that means is, in the case of my lending club model, ScienceOps will automatically track not only the source code of each version of the model that's deployed, but also the third-party libraries that are being used and installed, the metadata around each version that's run, so that be the user that's deploying the model, when they're deploying it, and then the actual artifacts or models themselves that are being used for a particular model. So what that allows you to do is, if, for instance, I needed to figure out why a particular decision was made on April 18th of this year, I can come right into our ScienceOps environment here, inspect that particular version, and then start to assess and figure out what's going on. And so to do that, we actually built out some additional functionality for tracking the individual data points that are being sent in and out of ScienceOps. So think of that as every time an API request is made to ScienceOps, everything is being stored and tracked in a database so you can get the basic statistics about the performance and the reliability of the system as a whole, but also, and arguably more importantly, you can start to drill down and take a look at the underlying data that your models are using. So, for instance, in the case of my lending club model that I just deployed, I can take a look and see how the distribution of my data inputs and my data outputs is changing over time. And in the event that maybe the underlying mean or the underlying data might be changing, or there's a spike in the number of missing values, that could be something that I would want to brought to my attention and something that I could investigate further. So apart from the API, you've got the decision management and auditing of ScienceOps. The last piece that I'll just touch on briefly before opening it up for questions is the system itself. So you might have heard me earlier. I mentioned that ScienceOps is a clustered architecture, allows you to scale horizontally. So that means being able to add servers and nodes to the system on demand. So whenever it is that you need more throughput, systems designed in such a way that you can easily add and remove hardware to fit those needs. So that is all that we have planned for the demo. We've got a few questions on the line that we can dig into here. Let's see. So the first one comes from Jeff. Jeff says, how do you deal with increased throughput to models? Cool, so that's pretty related to the system architecture. So part of what ScienceOps allows you to do is to, in addition to increasing your hardware, you can actually increase the amount of resources that are allocated to a given model. So in the case of the lending club model, right now we have one replication. That's just sort of a ScienceOps vocab for the amount of hardware or the amount of resources that a particular model is using. But I can on demand come in here and add additional capacity for a given model, update that in real time, and now what you can think of by adding 4 more replicas, I've increased the capacity for my lending club model to handle throughput by a factor of 5. So this is all accessible via our admin console and then also via an API as well for those of you who might have some sort of auto scaling or something like that in-house. Let's see, next question from Henry. Can you run Rodeo on a server? All right, Henry, excellent question. I didn't expect to field a Rodeo question, but I'm more than happy to. So Rodeo currently runs only on the desktop. We have installers built out for Windows, Linux, and Mac. We've got a new release coming in the next couple weeks that's going to be pretty awesome. We're really excited about it. Fixes a lot of some problems and add some features that we've had a lot of people requesting. So be on the lookout for that. We'll have a blog post in a few weeks. We are planning a server version of Rodeo, which is in active development and should be out towards the middle of the summer, so sometime in July or August. All right, let's see. Question from Andre. Do you run on Azure? So for those of you that aren't familiar with Azure, Azure is Microsoft's cloud computing offering. And to answer the original question, yes, we do run on Azure. Again, ScienceOps can run on really any platform, whether that's a cloud system like Azure or AWS, whether that's a data center that's running off-site, or whether that's actually on your own physical hardware that's inside of your company. Doesn't matter to us. It's very easy to install. Our last customer setup took about 8 minutes. Let's see, a few more questions came in, but we're going to wrap it up here just because running short on time. If we didn't get to anything, we'll reach out individually and we can go into more detail on anything that, any questions or any comments that you all might have. So thanks a lot for joining. I think I can speak for Austin, saying it was fun to show you guys what we've got, and look forward to speaking with some of you individually.